This is section 1.4, Extrema and average rates of change. Your I can statements for this section. I can determine intervals of which functions are increasing, constant, or decreasing, and determine maxima and minima of functions. And I can determine the average rate of change of functions. A function of f is increasing on an interval if for any 2 points in the interval an increase in x also increases y. So we know it's increasing if when the x's get larger, the y's also get larger. It's decreasing if the x's get larger, the y's get smaller. And we know that it's constant if our x values change, but our y values stay the same. So we're going to use the graph of the function to estimate intervals to the nearest 0.5 units on which the function is increasing, decreasing, or constant. So if we take a look at the picture, it does look like for the entire function it is going down. So we would say it's decreasing from negative infinity to positive infinity. But it does say we need to support our answer numerically. So we would just make a table of x and y values to show that it is decreasing the entire function. And if we make our table, our x values are shown. Remember to find your y values. You would just plug them into this formula right here. So I could do -2 times -4 cubed, and our value would be 128. As we can see from the table, for all the values of x, it is decreasing function. On this function, it is getting larger. The graph is going up until we get to the value of x is -1. So we are increasing from negative infinity from the left until we get to the value of x is -1. Then from -1 until we get from the x value from -1 until the x value of 1, our graph is going down, or it's decreasing. So we are decreasing from -1 to +1. These are the x values. You tell me what x value to what x value. Then we are increasing again from our x value of 1 and everything to the right, so from 1 to infinity. And we would support this numerically by making a table. As you can see, we are increasing. We're increasing from -3 until we get to -1. These values are getting larger. Then we are getting smaller over here from 2 down to -2. So from -1 to 1, we are getting smaller. And then we start from -2, we start getting larger again. So from 1 up, we start getting larger values again. The critical points of a graph are the turning points. You can draw a line that is tangent at the curve, and it'll either be horizontal or vertical. The extrema are the critical points at which a function changes from increasing to decreasing. And the point of inflection is where a graph changes its shape. So this is an extrema because it's changing from going increasing to decreasing. This is an extrema because it's going from decreasing to increasing. And this is a point of inflection because instead of being concave up, the graph is now becoming concave down. When you're dealing with maxima and minima, you can either have a relative maximum or an absolute maximum, the same thing with minimum. If it's an absolute maximum, it is the highest point anywhere on the graph, so this would be an absolute maximum. This point is a relative maximum because it is the maximum point relative to all the points around it, but it's not the highest point on a graph. Same thing down here. This is an absolute minimum, and this is a relative minimum because it's the lowest point related to the points around it. If the graph goes off forever, this is a relative maximum. You would not have any absolute maximums because the graph continues on forever, increasing in both ends, so there would never be an absolute maximum for that graph. So we are going to approximate to the nearest hundredth the relative and absolute extrema for this function, and we're going to state the x values where this occurs. So the first thing you would need to do is graph this on your graphing calculator. After you graph it, you would have a graph that looks like this. Now we can find the actual minimum and maximum relative values. So again, these will be a relative min and a relative max because they are going off in infinity in both directions. You cannot have an absolute. So on your calculator, once you have that equation into your y equals, you can hit the calculate button. So on your calculator, if you look across the top, if you have an 83 or an 84, you would hit second and then trace. That'll take you to your calculate, C-A-L-C. And you can go down and select a minimum. And you should get a relative minimum where x is approximately negative 1.76, and that'll have a y value that is approximately negative 22.81. We can do the same thing for maximum. You can calculate the maximum, and we will have a maximum where x value is approximately 0.43. And that's going to have a y value of approximately negative 1.93. The average rate of change is basically just your slope of a line, but it's the slope of the secant line. And the secant line is a line that's drawn that goes through 2 points that are selected on the graph. So we have f of x2 minus f of x1 over x2 minus x1. Remember, f of x is just your y value. So it's your y value for your x of 2 and your y value of x of 1. So to find the average rate of change, you're first going to plug in your values to find the y values that go with each x, and then just find your slope. So if we plug in the value of negative 2, so if we plug in our value of 2 for f of x, we're going to get a y value of 2. And if you plug in your x value of negative 1, we get a y value of negative 2. So our coordinates are negative 2, negative 2, positive 2, and negative 1, negative 2. This is your x1 and y1, x2 and y2. So we plug it in to find your slope of your secant line. Remember, it's just y2 minus y1 over x2 minus x1. Negative 2 minus 2 gives me negative 4. Negative 1 plus 2 gives me 1. So the slope of our secant line between negative 2 and negative 1 would just be negative 4.